On January 8th, physicist Michio Kaku drew widespread attention when he suggested that the tail of the interstellar object 3I Atlas had wrapped around Earth, blocking approximately 12% of the sunlight reaching the planet. According to this description, 3I Atlas appeared to be controlling a plasma tail roughly 94 million kilometers long, producing a precise and stable reduction of solar radiation at exactly 12% of value that lies beyond what would normally be expected from random natural processes. This sequence of phenomena was framed within the hypothesis of a highly advanced extraterrestrial intelligence potentially attempting to establish contact with humanity, as indicated by signals reportedly containing the coordinates of several major world capitals. At the same time, alongside this speculative interpretation, a more cautious scientific analysis was pursued, focusing on an intensive radio survey conducted at the Green Bank Observatory to search for technological signatures associated with 3I Atlas. What did this campaign ultimately detect? We will explore that result in the next section. Atlas entered observational focus as an interstellar object following a hyperbolic trajectory, and such paths are well understood within celestial mechanics, yet the behavior of its plasma tail introduced a variable that existing models could not comfortably absorb. Under normal conditions, a cometary plasma tail forms when solar radiation ionizes gases released from the nucleus, and the solar wind then sweeps those charged particles directly away from the Sun in a predictable radial pattern. This mechanism has been observed consistently across thousands of comets, and the physics governing it relies on well-tested electromagnetic interactions between the solar wind and ionized particles. Atlas, however, began to display a tail curvature that did not align with the expected solar wind direction, and this deviation persisted across multiple observation windows rather than appearing as a transient fluctuation. Data collected from heliophysics observatories indicated that the plasma tail of Atlas was bending at a measurable angle relative to the Sun-comet axis, and that angle remained stable over time despite changes in solar wind intensity. Such stability is difficult to reconcile with random turbulence because solar wind conditions are inherently variable and tend to produce chaotic, rapidly shifting tail structures. When Atlas maintained a coherent curvature, researchers were forced to consider whether an additional force component was acting on the ionized material. The anomaly deepened when particle density maps showed that the tail of Atlas was not dispersing uniformly, as would be expected from passive interaction with solar radiation. Instead, the plasma appeared confined within regions of higher coherence, as though the charged particles were being guided along an invisible framework rather than simply pushed outward. Atlas thus presented a situation where known forces were present yet insufficient to explain the observed geometry without invoking supplementary mechanisms. One hypothesis proposed that complex magnetic field interactions could be shaping the tail, particularly if Atlas carried an intrinsic magnetic field stronger than those typically associated with cometary nuclei. While natural magnetic fields do exist in some astrophysical bodies, the strength required to maintain such directional control over a structure extending tens of millions of kilometers would be extraordinary. Atlas therefore sat at the uncomfortable boundary, where natural explanations remained possible, but only at the extreme edges of plausibility. As models were adjusted and recalculated, each iteration reduced uncertainty in the measurements, while increasing uncertainty in interpretation, and this inversion of confidence is what unsettled many analysts. The plasma tail of Atlas was not merely reacting to its environment, because reaction alone could not account for its persistence, orientation, and internal coherence. Atlas seemed to participate in its own shaping not violently or dramatically, but quietly and consistently, as though following rules that had not yet been written. This realization did not confirm intent, nor did it confirm design, yet it introduced a subtle emotional shift among those studying Atlas, because certainty began to erode in places once considered secure. When familiar physics no longer closed the equation, the mind naturally drifted toward broader possibilities, even while discipline demanded restraint. Atlas continued its passage without acknowledging observation, and in that silence the first bridge formed between data and doubt, inviting deeper questions that would follow in the chapters ahead. When orbital analysts revisited the trajectory of Atlas, the discussion shifted from geometry to momentum, because motion through a gravitational field carries signatures that rarely mislead when measured carefully and repeatedly. According to classical mechanics, an interstellar object like Atlas should decelerate after perihelion because solar gravity extracts kinetic energy as the object climbs outward, and this pattern has been verified across countless hyperbolic visitors and long-period comets. Tracking data from deep space radar and optical astrometry showed that Atlas was not slowing as expected, but was instead gaining velocity at a steady rate measured at approximately 37 kilometers per second per day. This acceleration persisted over weeks, and the persistence mattered more than the magnitude because random forces tend to fluctuate, while systematic forces leave clean linear traces in long-term datasets. For Atlas, no corresponding increase in visible outgassing was detected, and this absence immediately complicated the simplest explanation, because conventional non-gravitational acceleration in comets is driven by asymmetric jets of sublimating ice. Normally, when gas escapes unevenly from a nucleus, it acts like a weak thruster, but such jets leave unmistakable signatures in the coma and tail structure that telescopes are trained to recognize. Atlas displayed no such jets, and the coma brightness remained stable, which forced researchers to confront a mismatch between cause and effect within known cometary physics. One proposed explanation suggested that Atlas might be expelling gas composed of extremely light or transparent species, which would evade easy detection while still producing thrust, yet even this required finely tuned conditions to remain consistent over time. Another possibility considered whether Atlas possessed an unusually low mass-to-area ratio, allowing solar radiation pressure to play a larger role, but radiation pressure alone could not account for acceleration, directed partially against the solar gravitational gradient. As calculations accumulated, models grew increasingly complex, and each additional parameter reduced explanatory elegance without restoring predictive comfort. Atlas thus occupied a narrow conceptual corridor where natural explanations remained technically viable, but demanded coincidences stacked so precisely that probability itself began to feel strained. This did not imply engines or intent, because extraordinary claims require extraordinary evidence, yet the data surrounding Atlas refused to settle quietly into familiar categories. For many analysts, the discomfort arose not from the acceleration itself, but from the realization that Atlas was challenging the reliability of assumptions long treated as universal. As Atlas continued to gain speed without visible cause, the anomaly became a bridge toward deeper inquiry, carrying observers from mechanical certainty into a quieter space, where explanation lagged behind observation and patience became part of the method. When high-resolution imaging finally resolved the central region of Atlas, attention shifted from motion to form because shape carries information that dynamics alone cannot fully reveal. Atlas had long appeared as a diffuse point surrounded by a faint coma, which is typical for distant comets, yet improved observational geometry allowed instruments to isolate the nucleus with unprecedented clarity. What emerged from the data was not a softly contoured or irregular body, but a structure with repeating planar surfaces that reflected light in a patterned rhythmic way. Atlas exhibited brightness variations that aligned with rotational phases, and those variations implied flat facets rather than the chaotic topography expected from loosely aggregated ice and dust. Geometric regularity is not unknown in nature because crystals form angles and planes under the right conditions, yet cometary nuclei are shaped by erosion, fragmentation, and thermal stress rather than slow lattice growth. Atlas therefore occupied an unusual middle ground, where geometry was present, but the environment that typically produces such order seemed absent. Measurements suggested 6 dominant reflective planes arranged with consistent angular relationships, and those angles repeated across multiple rotations without degradation. Atlas did not present a single smooth surface but a repeating pattern that persisted as viewing angles changed, which reduced the likelihood of coincidence created by lighting effects. Investigators compared the geometry of Atlas to fractured asteroids' contact binaries and known crystalline bodies, but no close analogue fully matched the observed configuration. Atlas resisted classification, not because it violated physics outright, but because it sat uncomfortably between categories that normally remain distinct. One conservative interpretation proposed that Atlas could be a fragment of a larger body that fractured along stress lines, producing planar faces through mechanical failure rather than design. While plausible, this explanation required an unusually symmetrical breakup process, and such symmetry would need to survive prolonged exposure to interstellar erosion, Another hypothesis considered whether surface sublimation could selectively erode softer material, leaving behind harder planes, yet this too required finely balanced conditions sustained over immense timescales. At-last again forced analysts to accept explanations that were possible though increasingly specific. The word artificial appeared only cautiously in internal discussions, not as a conclusion, but as a descriptor of geometry rather than intent. At-last was not being labelled a construct, but its form encouraged comparisons that scientists are trained to avoid unless evidence demands it. Emotionally, this stage marked a subtle turning point, because geometry evokes purpose even when none is proven, and the human mind is sensitive to repeated order. At-last remained silent and distant, offering no clarification, and in that silence the boundary between natural process and calculated form grew thinner, preparing the narrative for deeper structural questions yet to come. When infrared instruments examined the plasma tail of At-last in greater detail, the focus moved inward from outline to interior, because the internal distribution of matter often reveals more than the silhouette ever can. At-last had already challenged expectations through curvature and persistence, yet the deeper anomaly emerged when particle density maps showed that the tail of At-last was not homogeneous, drifting or smoothly diffusing into space. Standard cometary tails behave like expanding exhaust, where ions and dust spread outward with decreasing density as distance from the nucleus increases. In contrast, the tail of At-last displayed regions of compression and separation, forming elongated corridors where particles clustered along narrow paths rather than dispersing randomly. Data from space-based infrared observatories indicated that these density variations remained stable over time, even as solar wind conditions fluctuated. At-last therefore presented a tail that behaved less like debris and more like a structured flow maintaining internal order under external disturbance. One interpretation suggested that magnetic field lines could be channeling charged particles into filaments, because plasma is known to align along electromagnetic gradients. However, the scale of coherence observed in the tail of At-last exceeded what passive magnetic shaping would normally sustain, especially across tens of millions of kilometers. At-last appeared to maintain internal segmentation, with voids and concentrations repeating in patterns that did not collapse as the object moved through varying solar environments. This persistence mattered because transient plasma structures tend to dissolve quickly when conditions change, while the structures associated with At-last endured. Skeptics proposed that the apparent corridors were artifacts of data processing or projection effects, yet independent instruments reproduce similar distributions using different observational techniques. At-last thus reduced the likelihood that perception alone was responsible for the observed organization. If the tail of At-last were purely waste material, then entropy should dominate its evolution, gradually smoothing irregularities and erasing internal boundaries. Instead, entropy seemed locally restrained, as though energy were being applied not to accelerate matter outward, but to maintain separation within the flow. This observation did not imply construction, because architecture can emerge from natural processes under specific conditions, yet architecture without collapse requires ongoing balance. At-last once again occupied the narrow region, where natural explanations remained valid, but only with increasing complexity and diminishing probability. Emotionally, this stage deepened the quiet unease surrounding At-last not through spectacle, but through restraint, because order without explanation is more unsettling than chaos. The tail of At-last did not behave aggressively, nor did At-last display abrupt transitions, yet the suggestion of internal organization lingered gently in the data. As analysis continued, the tail ceased to be viewed as mere aftermath, and instead became a potential interface between motion and meaning. At-last moved forward without deviation, while the structured silence within the plasma invited a larger question, quietly bridging surface anomalies toward deeper considerations that would follow. When radio observatories first detected emissions associated with At-last attention shifted from structure and motion toward communication, because frequency choice can reveal as much intent as signal strength. At-last appeared briefly within a narrow band centered on 42 GHz, a frequency universally recognized in astrophysics as the hydrogen line, which is produced by the most abundant element in the universe. Hydrogen defines cosmic structure from interstellar clouds to stellar nurseries, and the hydrogen line occupies a uniquely quiet region of the radio spectrum where natural background noise is minimal. Because of this clarity, generations of scientists have proposed that an intelligent civilization seeking contact would select this frequency as a common reference point, and at last intersected that expectation with unsettling precision. The emissions attributed to Atlas were not broadband flares or random bursts which are common in astrophysical environments, but narrow stable signals that persisted long enough to be analysed. Atlas therefore entered a category reserved for deliberate transmission candidates, not because of signal strength, but because of spectral discipline and repetition. Further analysis revealed that the modulation of the signal followed mathematical sequences including prime number intervals and Fibonacci progressions, which do not emerge naturally from thermal noise or plasma oscillations. Atlas did not transmit images or language, yet the structure of the signal suggested intentional patterning, as though establishing common ground rather than conveying content. Such patterns have long been considered a universal handshake, because mathematics transcends biology, culture, and environment, and Atlas appeared to employ that principle without embellishment. Atlas did not repeat endlessly, nor did the signal escalate in complexity, which suggested demonstration rather than conversation. After several weeks of observation, the emissions from Atlas ceased entirely, and the abrupt silence carried interpretive weight equal to the signal itself. Atlas transitioned from presence to absence without warning, leaving no gradual decay that might indicate mechanical failure or environmental interference. One conservative interpretation held that the signal from Atlas could be a natural resonance coincidentally aligned with mathematical sequences, yet probability calculations made such coincidence increasingly uncomfortable. Atlas again occupied a space where natural explanations required fine-tuning, while speculative interpretations required restraint. The silence that followed the transmission did not negate its significance, because silence can represent choice as easily as incapacity. Atlas did not continue to announce itself, nor did it last attempt escalation, which shifted emotional response from excitement toward contemplation. In this phase, the narrative surrounding Atlas softened because communication without follow-up invites reflection rather than reaction. Atlas had demonstrated awareness of a universal constant, then withdrawn, leaving observers to question whether the message had been sent outward indiscriminately or inward with specific intent. As the hydrogen line faded back into cosmic background, the role of Atlas evolved once more, becoming less a speaker and more a mirror reflecting the assumptions embedded within the act of listening itself. When researchers began to quantify the forces required to shape the plasma tail of Atlas, the discussion shifted decisively from observation to feasibility, because energy budgets expose the boundary between what can occur naturally and what demands sustained intervention. The curvature, confinement, and persistence of the plasma surrounding Atlas could not be evaluated qualitatively, because plasma responds directly to electromagnetic forces whose magnitudes can be calculated with precision. To bend a plasma structure extending tens of millions of kilometers against the constant pressure of the solar wind, a counteracting force must be applied continuously, rather than in short bursts. Models indicated that for Atlas to maintain this configuration, an energy output on the order of 10 to the 19th watts would be required sustained across the full length of the tail. This figure is difficult to internalize because it exists far beyond the scale of planetary power systems, and even exceeds the combined output of all human civilization by many orders of magnitude. Atlas therefore forced analysts to compare this requirement not with terrestrial technology, but with stellar processes where such power levels are common only within stars themselves. The Sun emits approximately 3.8 times 10 to the 26 watts, which means the estimated energy involved in shaping the tail of Atlas represents a measurable fraction of stellar output, concentrated into a volume smaller than a mountain. Atlas thus introduced a paradox because no known natural mechanism allows such focused energy generation within a compact comet-sized object. Some models explored whether Atlas could be exploiting environmental energy rather than generating its own by redirecting solar wind plasma through resonance or magnetic coupling. While such mechanisms exist in principle, the efficiency required to amplify ambient energy to the observed effect would need to approach theoretical limits rarely achieved even in laboratory conditions. As simulations progressed, the energy problem surrounding Atlas became less about raw numbers and more about control, because producing energy is less challenging than directing it with precision over vast distances. Atlas did not simply disrupt its surroundings, but appeared to regulate them, maintaining stable configurations that resisted entropy and external turbulence. This distinction mattered because uncontrolled energy release produces chaos, while controlled energy produces structure, and the plasma tail of Atlas exhibited structure without violent signatures. Atlas therefore remained incompatible with explosive or transient processes, which further narrowed the field of viable explanations. Consultations with plasma physicists emphasized that even hypothetical advanced systems would struggle to manage electromagnetic fields at this scale without visible instabilities. Atlas showed no such instabilities, and the absence of turbulence suggested feedback mechanisms capable of constant adjustment. Emotionally, this stage of analysis marked a quiet escalation, because the energy calculations did not inspire fear, but rather a sober recognition of scale. Atlas did not threaten through excess, but through restraint, because restraint implies understanding. If the energy estimates were even approximately correct, then Atlas occupied a category of phenomena where capability precedes intent, and that order unsettles the human imagination. Atlas did not announce how such energy was sourced or applied, leaving the question suspended between physics and philosophy. As the numbers settled into consensus ranges, the energy problem ceased to be a speculative flourish and became a fixed constraint that any future explanation of Atlas must satisfy. Atlas continued its silent passage, while the realization took hold that whatever shaped the plasma was not improvising, but operating within margins that suggested planning rather than chance. When measurements confirmed that exactly 12% of incoming solar radiation was being reduced, the focus shifted from mechanics to meaning, because precision at that level rarely emerges from uncontrolled processes. Atlas was no longer only shaping plasma in space, because Atlas appeared to be modulating the flow of energy reaching an inhabited planet. Solar irradiance naturally fluctuates due to sunspots, orbital variations and atmospheric dynamics, yet those fluctuations occur gradually and unevenly, rather than locking onto a fixed value. Atlas produced a reduction that remained stable within a fraction of a percent, and that stability persisted despite Earth's rotation and the constant motion of both bodies through space. From a purely physical perspective, any obstruction capable of blocking sunlight should introduce noise and variability because plasma is diffuse and solar wind conditions are unstable. Atlas defied this expectation because the attenuation curve remained flat, suggesting active regulation rather than passive interference. Climate models were quietly consulted to understand what a 12% reduction would mean if sustained, and the results revealed a narrow and unsettling balance. Atlas had chosen a threshold that produced noticeable cooling without triggering immediate systemic collapse, and Atlas therefore sat precisely between harmless fluctuation and existential threat. This balance mattered because natural events do not optimize for demonstration while deliberate actions often do. Atlas did not plunge the planet into darkness, and Atlas did not merely brush the atmosphere with negligible effect. A larger reduction would have risked cascading feedback loops in weather systems, while a smaller reduction might have gone unnoticed outside scientific instruments. Atlas therefore appeared to occupy a pedagogical middle ground, where impact was undeniable, but survival remained assured. One interpretation framed this as coincidence, arguing that plasma density and geometry simply aligned to produce a 12% effect, yet coincidence struggles when precision persists over time. Atlas maintained the reduction with minimal deviation, as though continuously compensating for drift and dispersion. This compensation implied monitoring because maintaining a fixed outcome within a dynamic system requires feedback. Atlas thus entered a conceptual space where behavior resembled regulation rather than accident. Emotionally, this phase altered the tone of inquiry because the question was no longer whether Atlas could influence Earth, but why Atlas would choose to do so gently. Control demonstrated without destruction communicates capability without hostility, and Atlas embodied that ambiguity. If the reduction were intended as a message, then the content of that message was subtle rather than declarative. Atlas did not demand attention through catastrophe, and Atlas did not retreat into insignificance. The number itself carried weight, because 12% is neither round nor symbolic, yet it is large enough to matter in physical terms. Atlas offered no explanation for the choice, leaving interpretation to those affected. As days passed, and the attenuation held steady, the emotional response shifted from alarm toward contemplation. Atlas allowed time for measurement, discussion and modelling, which suggested patience rather than urgency. This patience deepened uncertainty because hostile intent often reveals itself quickly while observation unfolds slowly. Atlas neither escalated nor withdrew, and Atlas remained balanced between action and restraint. The reduction of sunlight became less a threat and more a question suspended above the planet, like a quiet demonstration. Atlas had shown that influence was possible, and by choosing moderation, Atlas left open the distinction between warning and invitation. When the new transmission from Atlas was decoded, the nature of the anomaly shifted again because the signal no longer spoke in frequencies or energies but in geography. Atlas embedded latitude and longitude coordinates within a repeating data structure, and those coordinates resolved into specific locations on Earth rather than abstract reference points. The locations associated with Atlas were not randomly distributed across continents, nor were they clustered around geological features or population centres alone. Atlas identified a limited set of sites that corresponded to political, administrative and organisational hubs where decisions affecting billions of people are routinely made. Washington, Beijing, Moscow, London, Paris, Berlin, Tokyo, New Delhi, and several others formed a pattern that transcended culture and ideology. Atlas appeared to recognise not just human settlement, but human structure, as though mapping influence rather than density. From a technical standpoint, this raised immediate questions because determining such locations requires knowledge beyond astronomical observation. Atlas would need access to detailed information about human governance communication networks or symbolic centres of authority. Humanity has never intentionally broadcast a catalogue of political capitals into interstellar space. Atlas, therefore, could not have acquired this information through passive listening to our strongest historical messages alone. One conservative explanation suggested that global radio leakage satellite traffic and communication patterns might indirectly reveal centres of coordination over time. Atlas, if capable of long-term observation, could theoretically infer importance by analysing traffic density rather than content. Another hypothesis considered whether Atlas was not identifying power, but accessibility, because these locations also serve as nodes where response and coordination converge. Atlas may have selected points where information moves quickly, rather than where authority resides symbolically. The emotional weight of this section did not arise from fear of targeting, because no action followed the coordinates immediately. Atlas did not accompany the list with demands, warnings, or instructions. Instead, the transmission repeated calmly, as though presenting a map rather than issuing a command. Atlas allowed interpretation to unfold without pressure, which complicated attempts to assign intent. If the coordinates were meant as an address, then Atlas demonstrated that it understood how humans organize themselves spatially and politically. Atlas showed awareness not just of a planet, but of a civilization layered upon that planet. This awareness unsettled analysts because it suggested that observation had extended beyond physical phenomena into social structure. Atlas did not select religious centers, cultural monuments, or scientific institutions alone, but places where authority and representation intersect. Some argued that the coordinates were symbolic rather than operational, functioning as a way to say we know how you are arranged. Atlas may have been demonstrating comprehension rather than preparing interaction. Others warned against overinterpretation, emphasizing that correlation does not prove intention. Atlas could have chosen these sites for reasons that remain invisible to human reasoning. What remained consistent was restraint because Atlas did not escalate after the coordinates were revealed. Atlas continued transmitting the same set without variation, allowing analysis rather than provoking reaction. This restraint shifted the emotional tone once more, replacing immediate anxiety with reflective unease. Atlas had crossed a conceptual boundary by acknowledging human systems, yet Atlas stopped short of engagement. The map became less a threat than a mirror reflecting how humanity defines importance. Atlas offered no explanation for the selection, leaving observers to confront the possibility that being understood does not require being addressed. When orbital solutions were refined for Atlas, the trajectory itself became a narrative, because paths through space carry history long before any interaction occurs. Atlas was confirmed to be travelling along a hyperbolic orbit, a mathematical signature that indicates an origin beyond the gravitational well of the Sun. Objects bound to the solar system follow elliptical orbits, returning again and again, shaped by familiarity and repetition. Atlas did not belong to this family because it last arrived once passed through and was never expected to return. The velocity of Atlas exceeded what solar gravity alone could produce, and that excess speed marked Atlas as a traveller shaped by another star, another environment and another set of formative conditions. Atlas therefore entered the solar system not as a resident, but as a transient crossing paths without obligation or attachment. Interstellar objects like Atlas are statistically rare in historical records, yet models predict that such visitors should be common on galactic scales. Atlas may not be exceptional in existence, but Atlas is exceptional in detection, because only recently have instruments become sensitive enough to notice such brief crossings. This realization reframed Atlas as part of a larger flow of material between stars, a quiet exchange that has likely occurred for billions of years without observation. Atlas thus represented not an anomaly of nature, but a reminder of scale where the solar system is not isolated but porous. However, while hyperbolic motion explains origin, it does not explain behavior. Atlas followed a path that was predictable in outline, yet within that outline appeared deviations that resisted easy categorization. The concept of an uninvited guest emerged not because Atlas violated boundaries, but because Atlas arrived without context. Atlas carried no history we could access, and no future we could follow beyond the edge of detection. This absence of narrative unsettled interpretation because humans rely on continuity to assess risk and meaning. Atlas offered only a brief window of observation, compressing analysis into weeks rather than centuries. Some analysts emphasize restraint, noting that hyperbolic trajectories alone imply nothing beyond origin. Atlas could be no more than a fragment ejected by ancient planetary chaos, wandering until chance aligned its path with ours. Others noted that chance operates differently across vast timescales, where improbable events become inevitable given enough duration. Atlas may therefore be neither rare nor significant except in the moment of encounter. Emotionally, this section grounded the narrative because hyperbolic motion stripped Atlas of mystery, even as it reinforced distance. Atlas was not approaching with intent because Atlas was already leaving. Yet departure does not erase influence, because transient interactions can alter systems profoundly. Atlas crossed the solar system like a sentence spoken once, brief but audible. As Atlas continued outward, the trajectory became a bridge between what could be measured and what could be inferred. Atlas reminded observers that not all visitors arrive by choice, and not all encounters require intention to matter. When the decision was made to listen rather than look, the investigation of Atlas entered a different domain, because radio observation searches for intention rather than structure. Atlas had already challenged visual models, yet radio astronomy offered a complementary approach, one grounded in the assumption that technology leaves spectral fingerprints distinct from natural processes. The search for extraterrestrial intelligence has long relied on narrowband scanning, because engineered signals tend to concentrate energy into extremely tight frequency ranges. Atlas therefore became a candidate not because of appearance alone, but because appearance invited the question of whether any form of transmission accompanied its passage. Natural astrophysical sources usually produce broadband noise spreading energy across wide swaths of the spectrum in chaotic patterns. Atlas, if artificial, would be expected to deviate from this behavior, using efficiency rather than abundance to communicate or operate. Radio observatories configured their receivers to scan between 1 and 12 GHz, a region often referred to as the quiet window of the cosmos. This band minimizes galactic background interference and overlaps with frequencies known to penetrate interstellar space with minimal attenuation. The assumption guiding the search was conservative rather than sensational. Atlas was not presumed to be signaling Earth, but rather that any technological activity might leak energy unintentionally, just as human systems do. In this framework, even a weak transmitter could be detected if its emission remained stable long enough. Atlas was therefore observed using high-resolution spectral analysis, capable of identifying frequency drifts caused by relative motion. These Doppler corrections are critical because a signal tied to Atlas would slide predictably across frequency bins as the object moved. Atlas offered a clean test case because its velocity and trajectory were well constrained. Supercomputing systems processed enormous volumes of data in real-time, breaking incoming radio waves into billions of discrete channels. Atlas was searched not for messages but for anomalies, because a single unnatural spike would be sufficient to warrant deeper investigation. The absence of such spikes did not immediately close the question. Atlas could remain silent for reasons unrelated to nature, including timing, directionality, or communication methods beyond radio. SETI methodology acknowledges these limitations openly because listening is always constrained by assumption. Atlas challenged those assumptions not by contradiction, but by compliance fitting neatly within the blind spots of the search. Emotionally, this phase tempered speculation because the discipline of listening demands patience rather than projection. Atlas did not reward expectation, nor did Atlas provoke disappointment, because null results are data rather than verdicts. The narrowband search framed Atlas within human definitions of communication, and that framing itself became part of the inquiry. Atlas asked an implicit question in return, not through signal, but through silence, inviting reflection on whether intelligence must announce itself to be present. When the Greenbank telescope was tasked with observing Atlas, the effort represented the most sensitive attempt to detect faint technological activity associated with the object, because few instruments on Earth can listen as quietly or as deeply. The dish at Greenbank spans 100 meters, and its design allows it to collect radio signals so weak that they are often described as whispers against the background hum of the universe. Atlas was observed during a carefully selected window when its distance and motion optimized detection probability, and the receivers were cooled to near absolute zero to reduce internal noise. Atlas, therefore, became the focus of an instrument capable of detecting emissions comparable in power to a consumer electronic device operating millions of kilometers away. The sensitivity threshold achieved during the observation meant that a continuous transmitter with a power output on the order of 100 milliwatts would have been detectable if operating within the scanned frequency range. Atlas, if emitting such a signal omnidirectionally, should have appeared clearly in the processed data as a narrow spectral feature drifting in frequency in accordance with its motion. The data pipeline at Greenbank applied multiple layers of filtering, removing known sources of terrestrial interference and compensating for Earth's rotation and orbital velocity. Atlas was tracked precisely, and its expected Doppler signature was modelled in advance, allowing analysts to distinguish potential signals associated with Atlas from background noise. Despite this sensitivity and preparation, no persistent narrowband signals were detected from Atlas during the observation period. Atlas did not reveal itself through continuous transmission, and this absence became a result as meaningful as any positive detection. It is important to understand that this outcome did not imply failure, because the purpose of sensitivity is to establish limits rather than guarantees. Atlas could only be detected if certain conditions were met, including transmission timing, frequency alignment, and emission pattern. If Atlas transmitted intermittently rather than continuously, the probability of interception would decrease dramatically within a finite observation window. Atlas could also employ directional transmission, focusing energy away from Earth, which would render even powerful signals effectively invisible to Greenbank. Advanced communication systems often prioritize efficiency and discretion, and such systems do not behave like beacons. Atlas, if technological, would not be required to announce itself, and silence would not contradict capability. Another consideration involved communication methods entirely outside the radio domain, where Greenbank's sensitivity offers no advantage. Atlas may operate within channels humanity does not yet monitor for messages, leaving radio silence as an expected outcome rather than an anomaly. Emotionally, the Greenbank results introduced calm rather than resolution, because limits clarify what was not observed without defining what exists. Atlas remained undefined not through lack of effort, but through the inherent narrowness of the listening window. The telescope heard nothing unusual yet that quiet refined the boundary of inquiry. Atlas passed through the most sensitive ear humanity could offer, and in doing so, Atlas revealed not its nature but the contours of human expectation. As the observation concluded, the absence of a detectable whisper did not close the narrative. Atlas simply moved the story forward from the hope of hearing something to the discipline of understanding what silence can and cannot say. One plausible explanation for the radio silence associated with Atlas involves direction rather than absence, because transmission does not require broadcasting in all directions to be effective. In this scenario, Atlas could be emitting signals through a highly focused beam aimed toward a specific target, rather than dispersing energy isotropically into space. Directed transmission is not speculative fantasy, because even human technology routinely employs narrow beams to conserve power and reduce interference. Atlas, if operating with advanced efficiency, would have little incentive to illuminate the entire cosmos when precision would achieve the same purpose. A tightly collimated beam would appear invisible unless Earth happened to lie directly within its path, and the probability of such alignment during a brief observation window is extremely small. At last, therefore, could be transmitting continuously, while remaining undetectable to instruments designed to search for omnidirectional leakage. This hypothesis gains relevance when considered alongside the energy constraints already associated with ATLAST. ATLAST would benefit from minimizing wasted output, especially if power is being managed with restraint rather than abundance. In directed systems, information is delivered selectively, and silence elsewhere is not an absence of activity, but a consequence of intention. ATLAST could be communicating with a destination entirely unrelated to Earth, using orientation and timing that render terrestrial listening irrelevant. Such behavior would not imply secrecy or hostility, but efficiency, because directionality is a hallmark of mature engineering rather than aggressive concealment. ATLAST in this light would be behaving in a manner consistent with optimization rather than avoidance. The emotional implication of this scenario is subtle, because it removes humanity from the center of the narrative without diminishing significance. ATLAST may not be ignoring Earth, but ATLAST may not be addressing Earth either. This reframing alters the psychological tone because being unnoticed is less threatening than being targeted, yet it is also less comforting. ATLAST becomes an actor within a larger system, where Earth is a waypoint rather than a destination. Directed beams also align with the earlier observation that ATLAST demonstrated precision without excess. ATLAST has repeatedly shown behavior consistent with controlled application rather than indiscriminate output. If this hypothesis holds, then radio silence ceases to be evidence of absence and becomes evidence of selectivity. ATLAST would not need to announce itself to be active because activity does not require acknowledgement. As a result, the directed beam scenario preserves both natural caution and speculative openness. ATLAST remains compatible with advanced behavior without demanding conclusions beyond the data. This interpretation gently shifts the inquiry away from detection failure and toward perspective limitation. ATLAST invites reconsideration not of what is being sent, but of where humanity is positioned relative to the flow of information. Another explanation for the silence surrounding ATLAST considers not direction but medium, because communication does not have to occur within channels humans are accustomed to monitoring. In this scenario, ATLAST may be operating through forms of signaling that lie outside the electromagnetic spectrum traditionally used for communication. Radio waves are effective, but they are also slow, diffuse, and vulnerable to interference, which makes them an inefficient choice for highly advanced systems. ATLAST, if operating beyond human technological paradigms, would have little reason to rely on methods that favour simplicity over performance. One proposed alternative involves neutrino-based communication, because neutrinos pass through matter with minimal interaction and can travel vast distances without significant loss. ATLAST could transmit information encoded in neutrino flux rendering radio telescopes irrelevant regardless of sensitivity. Another speculative channel involves gravitational modulation, where minute distortions propagate through space-time itself. ATLAST, if capable of generating controlled gravitational signatures, could communicate through patterns invisible to conventional detectors. Quantum-based communication has also been suggested, though such mechanisms remain largely theoretical at macroscopic scales. ATLAST could be exploiting principles not yet accessible to human engineering, operating within domains where observation tools have not been designed to listen. In all of these cases, radio silence would not reflect inactivity but incompatibility between sender and receiver. ATLAST may be communicating constantly while Earth remains functionally deaf. This scenario reframes the narrative away from detection failure and toward perceptual limitation. ATLAST does not hide, because hiding implies awareness of being observed, while this explanation requires no such assumption. Emotionally, the exotic communication hypothesis carries a quiet humility, because it suggests that intelligence does not need to accommodate those who cannot yet listen properly. ATLAST becomes neither secretive nor evasive, but simply unconcerned with accessibility. This interpretation aligns with the broader pattern of ATLAST exhibiting restraint rather than exhibition. ATLAST has not overwhelmed systems with noise, nor has ATLAST attempted redundancy through familiar channels. If communication is occurring beyond radio, then the absence of detectable signals becomes expected rather than troubling. ATLAST would be operating normally within its own framework while humanity remains constrained by its tools. The exotic communication scenario does not assert superiority or intent, but it widens the conceptual space in which silence can exist. At-last remains active in possibility, even as at-last remains silent to the instruments designed to hear echoes of ourselves. A third interpretation removes intention entirely and considers that at-last may be artificial in origin, yet inactive in function, because technology does not remain alive indefinitely once its purpose has ended. In this scenario, at-last would be analogous to debris, a relic drifting through interstellar space long after the civilization that produced it has vanished. Human history already offers small-scale parallels because satellites, probes, and discarded hardware continue to orbit Earth long after contact is lost.